Right. Hello there. Welcome again to the CL501 course in UM-DAE CEBS in the School of Chemical Sciences. As you know, we are going to do all the experiments in this course by learning the practical aspect of all the different techniques, principles, what we had learned in the previous semesters. Now what we are going to do today? We are going to do soil testing. It's an interesting and a very important field, right? We are going to find some parameters of the soil which are quite useful and necessary to be looked at if you are wanting to have a good yield for a particular crop. So what we are going to measure today for the soil testing? We have some samples for the soils from the different locations, and we are going to measure pH, right? Now pH, it is going to tell us whether a soil is good for a particular crop. Now what do I mean? By meaning I have some values written which I had just got it from internet. Like for instance, pumpkin likes pH between 5.5 and 6.5, slightly acidic. Right, for pumpkin 5.5 to 6.5, right? This is just of the internet value. Now if it is a slightly acidic, which is more good for the pumpkins, better crop what we can harvest, it doesn't make any sense if your soil is having a pH of an 8. You are putting in all that effort, all those chemicals, all those seeds for nothing. So it's very important. If you are wanting to grow strawberries or blueberries, the likable pH could be somewhere around 5 to 6. Again, an acidic ones. For the crops like gram, which is mildly alkaline, like 8 pH is more recommended for the gram. And for most of the other crops and the vegetables, it's close to the neutral range, what we are looking for. Now, if you are having an off balance of pH of your soil, it is dramatically going to affect the crop productivity. The second parameter what we are going to see is conductance. Yeah, conductance. Now why it is so very important and why this conductivity is all about from the in the soil? It is because of the soluble ions which are present. We are not distinguishing whether it is a monovalent or a divalent or a trivalent. It is the net ionic content which tells us. Too much of an ionic content, too much of a salinity, then you don't get any good good crop for your field. The next parameter what we have to measure again is the percentage moisture. Right? This is the ability of the soil to retain water. Extremely important, right? If it's not visible, the white. Okay. Let's try with yellow then. Is it better? Yeah, percentage moisture. Right? As I said, it's the ability of the soil to retain water. Extremely important. Yeah, for the soil like sugarcane and all, which really requires a lot of water. Rice, for instance, it requires a lot of water. So again, that we are going to measure here. And last, we are going to see the organic content of the soil. Now what is the organic content of the soil? Of course, it is required for a better growth for any germinating seeds, right? A better organic content would mean your plants will grow better, right? It's that simple. Now, how do we get the sample of the soil, right? Now for instance, this is my field. Yeah, it can be any shape and size. In India, we get different sizes of different shapes of field. Suppose we have a symmetric field, for instance. Are we going to take sample from one side and send it for the testing? The answer is no. We have to be very careful about from which different places we get the soil. We take it from the different location, right? They say you preferably go in a zigzag fashion, like this. Now let's say we take sample from here, 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 at different locations, right? Now how those locations should be? There should not be any tree from where you collect the sample. There should not be any grazing animals. It should not be a pasture land where the animals graze, because their dung is going to affect the soil testing. It should not be very close to the water source, yeah, the canals around around the field, the water drainage. It shouldn't be taken from there. It should be somewhere in the middle of the field. Now typically we send 500 grams of sand, the soil, for testing. Now what do? Let's say we start off with digging the pits, small pits. Now what kind of pits we dig at each and every location? This is something like a V-shaped pit, what we dig, right? Now this V-shaped pit, how deep it should be? It should be like around 6 inches, or let's say 15 centimeters, like a small scale which kids use in their compass box, yeah? So that deep it should be for majority of the things. But if you are growing any vegetable or crop which is having its going deep into the ground, then you have to dig up to 1 feet, yeah, and then take this out. Then you scrape the soil from the sides of this V-shaped pit, right? Let's say you take roughly around 500 grams from each location, and you had taken from the 10 different places. So it's close to it's like 5 kilograms of sand. Now I said we have to send like 500 grams of sand, and what do? Right? So you take all of those, put them together. You put all the soil together, all 5 kg of it, right? And then with hand you can make 4 parts, right? 4 parts, and remove the diagonally opposite soils and mix the remaining soil and repeat the same exercise, right? So you repeat the same exercise, do it again, because your soil has become small in amount, right? Cut it through again into 4 parts, remove this part, yeah, maybe that is better. So it goes, it flies off. Remove this part, remove that part, mix it again. And you do this exercise until you are left with 500 grams of soil, right? And that's how you collect soils from different locations. And now what we have today, so we have today soils from 4 different locations, right? And we are going to measure the 4 parameters, as I said already. Using pH meter, we are going to measure the pH, and also we have the universal indicator liquid. We are going to see if our pH meters are giving the good values. Then with the conductivity meter, we are going to measure the conductivity, moisture content. We'll show you how do we measure in the oven, and also we are going to measure the organic content. Now how are we going to measure the organic content? We are going to measure the organic content by using Walkley-Black method. Now what do you do here? Yeah, so you take the soil, let's say 5 grams of it. To it you add potassium dichromate, yeah, and then you use sulfuric acid to catalyze the reaction, and you oxidize all the organic content to it, right? So So whatever is the organic content there will be oxidized using dichromate because it's an oxidizing agent, a powerful oxidizing agent. Whatever remains, we do the back titration by using ferrous sulfate. Right? Very simple experiment. These are like some of the experiments which you have already done. Remember, we are going to apply all of that knowledge, what we know. Right? And for doing all of these, I have again a very strong support team. It's Sonali. Sonali, can you please come here today? So that's Sonali.
Hello.
Yeah, hi. And we also have Mayuresh with us. So they are going to help me to demonstrate this experiment to you. And of course, the henchman Rupesh is always there. Can you turn around, Rupesh, and say hi to the people? Yes, there he goes.
Hi.
All right. Without him, the recording won't be there. And they are Sandesh and Abhijit. Yes, so they are also a good helping hand to us. Right? All right. Let's go. Now, what we are going to measure first is the pH of the. We start off with the pH. Okay. But to measure the pH, we have to process the soil. Right? Now, what kind of samples do we have? So, can you show us the samples? Come here, okay. See? Can you see? We have different soil samples from different locations. That's the first one. Yeah? This is from the garden soil, right?
Sand.
Sand. From where we had collected this sand? Yeah, premises of CBS, yes, around. This is?
Garden soil.
That's the garden soil where all our flowers grow for the institute. And this one is?
Red sand.
Red sand, yeah. So this is we got from one of the forest areas in Raigad. Yes. And this is?
Red rock soil.
Yeah, that's again the red rock soil. Again from a different location of Raigad. But we have got this red rock soil. Now what do? You take the soil, yeah, let's say 5 grams of it or 10 grams of it, you decide. If you are using 5 grams, use 25 ml of water. Then you make a nice slurry out of it. Yeah, nice. And then you filter it through Wortman filter paper 1. Now one good small technique I would like to share with you. This is like the Wortman filter paper number 1, right? If you do this and make a funnel out of it like this, right? And then if you straight away put it in the funnel, so it will touch to the sides of it. Yeah, and then there won't be any air pocket and your filtration process will be very slow. Now to save your lives, what I would recommend, the same filter paper you make as a fluted paper. What do you do as a fluted paper? You make the Japanese fan out of it. That's it. You do like this and then you open it up again. You see this like this? Now this is what is the advantage. You get this nice air pockets and this saves your life by quite a bit. Okay? I'll say your filtration time will be reduced to half. Yeah, it can be better. And this is what such kind of slurry, if you put it through, these are the kind of solutions what you will get. So these are the filtrates. Now these are the kind of filtrates what you will get. Not necessarily for every soil you will get a clear solution like this. The red soil itself has its own color. So even if you filter it, you will get some reddish tinge over here. But nevertheless, we had taken care to remove all the particulates, right? The other soil is quite red in color. Yeah. But we have to live with it. That's how the nature of the soil is. Now, can we first measure the pH for it? Yeah. Now, Sonali is going to help us. So, we are going to take to the pH meter. Yeah. We are moving towards the pH meter which we had calibrated and kept already. right? And these are the calibration solutions. So we had used these solutions, calibration solutions, for calibrating our pH meter. This is pH 4, pH 7, and pH 9. So you calibrate this instrument across the range, and then you start measuring it. Yeah. She's cleaning the probe.
Now our first
Yeah.
filtrate of red rock soil.
Red rock soil. You dip it. So you have to make sure. Can you remove your hand, Sonali, so that they can see? The probe has to dip into the solution. Yeah. You see that small hole? Yeah. That hole in the probe. Yeah. Here. Turn it around. Turn it around. The beaker. Yeah. This hole should be dipped in the solution all the time. Yes. What's the pH we are getting?
5.5.
5.5.
5.8.
9, so you say 5.6. Yeah, so we
Yes.
say our pH is like 5.6. Right? Can we note it down on the board? Yeah, Mayuresh, you can write it. The pH for red sand, you can make a table. Sand as one column, different soil as one column, then that's the second sample, right?
Yes,
This
sand.
is,
This is sand.
yeah, we have to wait until it stabilizes. Can you focus it onto here? It's a bit fluctuating. You have to wait until it stabilizes. Is it fully dipped? Can you tilt it? Yeah, now it is fully dipped. See, this is what happens. If it was not fully dipped, then you won't get this stabilization. Now we are getting towards. Yeah, still it is going up. Oh, it's moving towards an alkaline nature, huh? Wow. Which one you said it is?
Sand.
It is the sand. We got it from the beach area. Yeah, it's kind of stabilized. I'll say it is 7.9. Yeah. So Mayuresh can make a note of 7.9. You can use. Yeah, it's okay. You can leave the second digit. So just give a water wash to the probe. Yeah, there. Well, after every measurement, you are giving a water wash before you dip it into the next sample. There you go. That's dipped in, and it turns out to be somewhat acidic in nature. Let's see until what value it goes. It takes some time before it stabilizes. Still slowing down a bit. Yeah, kind of. I think it will be a safe bet if you say 6.2 as the pH. Yeah, you can say it as a 6.2, and yeah, 6.2. And the last sample, right? Now this is,
Garden soil.
yeah, that's our garden soil of our institute, CEBS. Beautiful flowers growing there. right? Wash it again. Yeah, and there you go. Dip it. Yeah, going on, going on, going on. Let's, yeah. Can we say it is 7.4 on a safe bet? It's mildly alkaline. Mildly alkaline. Very pretty much like a physiological pH. Right. So we have to wash back the probe. Put it, yeah, nice and clean. Put it back in place. Yeah. Of course, you have to close the probe. There you go. Hang in there. Right. So you can take one of the samples for demonstration purpose. What is that? Sand. Yeah. Let's take sand. It's a clear solution. So now we are also measuring the pH using this liquid indicator, pH liquid indicator, the universal one. Can you see? You have this liquid into it, right? And when you put this liquid, now depending upon their pH, you should get the different color formations on that liquid. Now what Sonali is doing, she has taken a little bit of this sample. Yeah. And there you go. I'll open it for you. Put a drop or two, should be enough, and see what do we get. Yeah. Oh, can you see that? The colorless to green color, and you can just see it to what closeness it has. Yeah, I'll say it's 8. What do you think? Yeah, it's 8, and that's what we measured. What did Mayuresh write over there? Yeah. So it's 8 and 9. Yeah, it's 8. Yeah, close to 8, and that's what we see. So, anyways, we have seen that the pH of the soils can vary now depending upon their location. It's very crucial that we should have an optimal pH based on the crop we are wanting to have. Also, the next thing what we are going to measure is the conductance, right? For that we will be needing those samples again. Yeah, so one sample we have already over here. Let's move this drop. We have, and yeah, I'll put this dropper here. Can you measure the conductance for the first sample? So this conductance is essentially because of the total ionic content what it has. Doesn't matter what oxidation state it belongs to, whether it's monovalent, divalent, trivalent material. How much it is? The first one?
186.
186. Right? 186 microsiemens per centimeter. This is what our pocket conductivity meter measures. But for the soils, a very standard way of reporting will be decisiemens per meter. That's how we report the conductivity of the soil. Now what we have is a microsiemens per centimeter, right? All you have to do is make a conversion. You will get all those values at the end when we will focus things on the board. We are writing as and when we are measuring onto the board. Mayuresh is doing the needful, right? We can wash the probe again nicely with water. Yes. Good. That's it. Clean it up, please. Yes.
Second sample.
Second sample. Which one is
Red rock soil.
red rock soil? Yes. What does it say?
70.
70? 70?
70.
Yeah. So it has to be written as 70 on the board. Yes. Alright. Wash up again, please. Right. There you go. Nice and clean. Probe is ready. Okay. The next one is
Red sand.
red sand. Yes. Red sand again. What's the reading say?
70.
Again 70?
Yes.
Yes, it is a 70 red sand. Right, okay. Now, if there are more salt, yeah, so this is a direct measurement of salt, the soluble salt. What would it mean? Yeah, salinity. High salt, high salinity, more barren the land would be. So you would prefer that it is not too high, right? Okay. So that's the fourth sample we are going to measure. What does it say?
Garden soil.
That's a garden soil, yes.
51.
All right, 51. The garden soil is 51. Okay, so we had also measured the conductivity, right? Now, for the moisture content, what do we do? Now, the samples you are seeing over here, they are already dry. Can you feel it? It's quite dry. It's very dry. So what we had done for the moisture content, very simple thing, very simple. We had just taken the soil as we had collected, right? And it's a monsoon season all over, so it is nice and drenched already. And we had kept it in this oven. Yeah. Now before keeping in this oven, what do? We measure this petri dish. Can I have an empty petri dish, please? We will wait Mayurish to get us the petri dish. You can pass it over here. Right. You weigh this petri dish, right? Okay. And on the balance, yeah. So weigh it. You weigh the petri dish. Yeah. You make a note of it, right? And to this you add 5 grams of whatever soil you had collected, right? Now let's assume this is like the soil as we had collected, and then you do simple one thing is put this soil, yeah, into the oven, close it, set the temperature of the oven to 105 degrees and keep it overnight for drying, yeah. And after drying you measure the petri dish plus sand again, and whatever is the loss you will see will be the loss because of the moisture, right? And that's how we had just calculated a simple percentage moisture loss. Of course, one can argue there are sulfur contents and all which might have gone, but they are in minuscule amounts, so it doesn't make too much of a difference, right? Mostly it's the moisture what is being lost. Now the last part we are going to do, yeah, it is a bit lengthy, and it's Mayuresh who is going to help us. Meanwhile, we are just going to make some space for him to do it. Now we are going to measure the organic content of the soil, right? Now how much of soil you are taking, Mayuresh, today? How many grams?
We will be taking 1 gram.
1 gram. So he is going to estimate whatever is the organic content in the 1 gram of soil, right? And that's what he has done. He has taken the 1 gram of soil, putting it into the conical flask. Fantastic, right? And then to this we are adding potassium dichromate. right? That's the tube you have. Oh, I'll pick it up. Don't worry. Okay. Right, so this potassium dichromate, we are going to use it as it is an oxidizing agent. Okay.
So we will be taking 10 ml of potassium dichromate.
Yes, that's the 10 ml of potassium dichromate, and then we are going to put it into the soil. There you go. There you go. Huh? Slow and steady. Slow and steady. Right. Now to this, we are going to use sulfuric acid, concentrated sulfuric acid. Yeah, 98% weight by volume. Yeah. For that, we will be working in the fume hood. Rupesh, can you please come with us? Right, can you turn on the suction please? Yeah, there it is. Close it, and you are adding sulfuric acid. We had already measured it. He's adding 10 ml of it, right?
Yes.
See this. Can you see the reaction happening? So much of fume. That's why this process is better to be done in the fume mode. We have to wait until the reaction is over, all the fumes are gone, and then it is safe to take this flask out again. Yeah. Right, steady. Shake it a bit. And the reaction goes faster. Yes, yes. It makes some hissing sound, and I'm not sure if you are able to hear it in the noise of this fume mode. Is it done? Yes, it's done. Fine. Turn off. Yeah, the suction is stopped. It's quiet again. Now we move towards the titration. Okay. Can you proceed?
No, we have to heat it
Yeah.
for
Yes. That's a preheated hot plate we have got here. At 130 degrees it is being set. So we have to heat this reaction mixture for about 30 seconds, 40 seconds. Yeah, it's certainly hot. I can feel it. Yeah. Yeah, you can see some reaction happening, some bubbling happening. Yeah, nice, really nice. Yeah, there it is. There it is. Yeah, few more seconds. Few more seconds. So we have to make sure that all the organic matter is being converted. It's being oxidized. We have to really make it sure. Yeah, should be enough. Yeah, please get some tools to pick it up. Yeah. Now, if you don't have tongs, you can always make tong of your own. Yeah, so that's always a quick makeshift. What you can always do, you can have a tissue paper like this, make it double, fold it like this, across like this. Yeah, you can handle it from here in English. You have to cool it down. not direct, it will break. So you have to let it stand outside for some time. Yeah, if you directly plunge it, it's going to break the conical flask. So you have to wait until it comes to the to cooler. It's hot. I can feel it. It's hot. Yeah. So let it cool down a bit, like this. Of course, while during the video we don't want it to break, right? That will be so embarrassing. No embarrassments. Yeah. Still hot. I can hold it, but I can feel it still hot. Yeah. Yeah, you can see this, Mayvesh. It's all right. Now you can cool it down. Now it is cooling, so let it cool it down. In meanwhile, we can do the blank. Now, in the blank, what we had done, you would put everything, you process everything. You put the dichromate, you put the sulfuric acid, you heat it the same way, but no soil, right? And this is the blank, what we already have. Yeah, it will cool down the soil sample. In meanwhile, we will do the titration of the blank. Okay. Now, that's the already processed blank for demo. Yeah, we are going to demonstrate you. So, we are going to titrate it against ferrous sulfate. Now, this is the blank as it doesn't have any soil, no carbon content, so it should actually have all the dichromate available for the titration. So, it should in principle show us the highest value, right? The highest value. Now, whatever soil we use, all right, if it is consumed, you will be left with the lesser amount of dichromate, yeah, sensibly. So when you titrate in, now if everything goes right, let's see whether things are right or not. If the thing goes right, then our soil sample, if they are rich in carbon content, they should not exceed the blank ones, the blank values. Or at least if there is no carbon content in the soil, then it should remain at all the close to the blank value. Okay, now this is the blank and that's the indicator, ferroin indicator, right? You go through the protocol of Walkley-Black chromic acid indicator. There is also composition given how to make this indicator. Prefer to make it fresh, right? Prefer to make it fresh. Whenever you make this indicator, please cover it up with an aluminum foil because we don't want any degradation because of the light. Now, we are going to find the carbon content, right? So this is the dichromate solution. That's the blank one. Is that the right one? Yes, that's the blank one. It doesn't have any soil, so that will be our control. All right. So when we will put up the soil, whatever soil is oxidized, right, we will back titrate and we'll see how much of dichromate is remaining, because dichromate is a nice strong oxidizing agent. For the titration, we are titrating it against ferrous sulfate. Can you see the lower meniscus? It is right up here. It is fully filled, right? Now I can ask Mayuresh to carry on the titration over here. So he picks up the blank one. Rupesh, can you come on this side and focus on this one? The flask, I'll move this to make some space. Alright, so he is going to add ferroin indicator. And we had optimized that 5 drops works the best. So he's going to add 5 drops. That's 1, 2, 3, 4, 5. Okay, quite colorful indicator, right? So we are going to start titrating in and let's see what kind of color change do we get. He moves a burette bit up to make some space. Right, goes underneath. Right. So against the white background, you can see it here. You can pinhole only the neck part of the flask so that people can see. Yeah. So he goes drop by drop. Yeah. There it goes. He starts. Right. Can you already start seeing change in color? Keeps going, keeps going, keeps going. Right. Let's see what color do we get. Yeah, see, can you see the yellow color getting lightened up? Yeah, it is slowly turning towards green now. You can see I'm not very sure if that's very obvious in the video, but we can see it is slowly turning towards the greenish tinge. Right, right. Now it's more obvious. So remember, it was quite orange in tinge. It is slowly becoming green. Going. Now it is becoming dark green. So it's a slow transition, what you will see, towards the formation of this green color. Right. Keeps going, keeps going. Keep going. Right. So see, it's becoming more and more green. So it's a slow transition. So this is certainly not the end point. We shall see what kind of end point do we get. Right. Going on. Yeah. Now, wherever the drop is falling, you are able to see this formation of red color. Rupesh, if you could zoom in where the drop are falling. Yeah. Can you see a reddish brown wherever the drop is falling? Now you go extremely slow. Yeah, there you go. Stop. That's the end point change. Yes, it is. Almost there. One drop at a time. You shake it and see if it comes back to green. Add a drop more till it's permanently red. Yeah, a nice red color. That's our end point. Right. Now, likewise, can you refill your burette? Bangladesh? Yeah, you can refill the burette. Yeah, there you go. And you have to come in the level to see if it is nice. The lower nicely the lower meniscus matches the upper mark of 50 ml. Yeah. Right. Now that's the sand soil sample we have got, and likewise we'll be titrating all the other sand samples. Right. There it goes. Okay. Let me get rid of this paraffin. Again, there goes the 5 drops. It's 1 and 2 and 3 and 4 and 5. There it is. Yes. Okay. Let's go again. Let's see. Do we get the same color transition here? Right. Okay, it is now going towards green. Can you see that? The change in color from yellow, orange to green. Yes, it's becoming dark. That's a very nice green shade what you get just before the transition. That's a beautiful color. But slowly but surely the yellow color is disappearing. Yeah, my yellow orange shade is going away. Yeah, still a bit yellow. Okay, okay. Okay, that is almost gone. Almost gone. Can you stop for a while, Mayurish, to show them that the yellow color is almost done. We are done with all the yellow color. It's quite green. Now we can continue further. Right. Going on again. Then. Right. So you have to be extremely cautious once you start seeing that brownish complex formation. Yeah, this the green color I was talking about. I really like it. Yeah, see, now you go very slow. You with every drop you are seeing the red. So you put the drop, swirl it, and see if the green color comes back until it is permanently red. Is it permanently red? Yes, it's permanently red. Yeah. Blank versus our sand soil sample. Right. You can already see there is probably some organic component is there in this sand soil sample, but we shall see after doing all the calculations. But this is our blank and that's our soil sample. Likewise, all the soil samples will be processed, titrated, and the readings will be noted. Already have it for you, right? For all the titrations we already had done it. So this was the demonstration, like what kind of color change and all what we are going to do. But for all the samples when we had done together, we already have some of those values written over here. Now, can you write over there the organic matter for the blank? What were the values written there?
For blank, 19.1.
Yeah. 19.1 when we had already done all these samples, because it's a lengthy procedure, so we had already done it for you. Yeah. And then for the red sand. Yes.
14.3.
14.3.
Garden soil,
Yeah.
12.1.
How much?
12.1.
12.1. For the red
Sand.
rock? Yeah, sand. Okay.
16.6.
16.6. And red rock?
23.5.
23.5. Now, this is what I meant. Yeah? What I said, if there is no organic content in it, then you should be getting at the blank volume. So the volume for the solution should be like at least the blank. Here we are getting the volume higher. Right? What can be the reason? Right? Are we having some oxidizing agent already in the soil in addition to the dichromate? Is that the case? This is what needs to be thought about. Right? You can see very well our blank is 19.5 milliliters. Right? Now the concept is more the organic content, more the dichromate will be used up. Yeah, lesser will be the volume of ferrous sulfate which will be required. Now for the garden soil, 12.1. Red sand, it is 14.3, and for the sand it is 16.6. So as we are getting the least volume of ferrous sulfate, right, for the soil for titration, then this means this is having a rich organic content in it, and that's what we see. We got it from our garden where all the flowers bloom, right? You can pause the video and note down all these values, and you can make your own conclusion, right? To comment what are it. Now one thing what we also have to tell you is the percentage moisture content. Remember the 5 grams sand what we had, the soil sample what we had kept in the oven. So what we will write is the difference in weight what we get, right? Can you tell us the difference, or do you have both the values with you?
5 gram we took.
Yeah,
and
5 gram.
After drying, we got 3.908 weight of the dried sample.
Yeah, okay. For 3.908 for which sand?
Red sand.
Red sand.
908.
Okay, I'll say 3.9 grams. Right. For the garden soil, after you dried 5 grams, how much did you get?
3.9.
This is also 3.9. Very good. So they both retain similar amount of water. Then red rock
4.9.
4.9. Almost no loss. So there was no water, it looks like. And the sand
4.7.
4.7. Again, not much of water retention capacity shown by the sand. Right? So you can note down all these values that will be required for your report. Right? And that's all we have to say today for this soil testing. Right? What we haven't done. Right? This is not all. The important thing is the NPK estimation, nitrogen, phosphorus, potassium. Now most of the cases these days those rapid testing kits are available. You can buy off the shelf and then can use it. It's very simple. We couldn't do potassium estimate because it requires flame photometer, which we don't have right now. Some of the chemicals required for estimating nitrogen and phosphorus also are not available with us today. Maybe in the next video, whenever those chemicals are available, we can make use of it. But the potassium, yes, in absence of flame photometer, we couldn't do it, although the processing is very simple. But nitrogen, potassium, phosphorus, NPK is very important in addition to these different parameters, right? But nevertheless, this particular practical serves its purpose, that all what you had learned in the previous semesters can be put into use, the practical application of in day-to-day life, right? Okay, this is me, Avinash, signing off for today. Bye and take care.